Another IAEI News Live. My name is Thomas Dimitrovich. Today, we are going to talk about energy management systems and the NEC. Specifically, we're going to take a look at NEC 2023 and some of the developments that have occurred over this past cycle, recognizing energy management systems, which has been in the code for a while. So that's our topic. Our topic is energy management systems and NEC 2023, and it all starts now. Okay, welcome. Hopefully everybody out there is doing good. Whoa, hold on. I didn't go anywhere. I'm just getting situated. Got to move some things around because this desk just isn't working for me. Well, Lou Petrucci, we've got Lou online. I saw David Engelhart. Thanks for joining us, brother. Robert from Omaha. We got the whole crew. We got the whole crew. So hopefully all of you are ready. And yes, Robert, we're going to talk about those changes made for Article 750 and much more. So much more. Get your reading glasses out if you need them. Get your edition of the 2023 code. Or get NFPA link. Get NFPA link. All right, Lou, Robert, and David, and anybody else out there, we're going to get started. But first, I got to show you a treat I got in the mail. It was a week ago. Mr. Wages was hoping I'd get it for the IAEI News Live that I was doing that day, last Tuesday. I think what did we cover last Tuesday? We covered the disconnect last Tuesday, remember? Service disconnect. Service disconnecting means. Well, I got it in the mail after that, and look what we got. I got a mug. But that's not the most important part. The most important part of this mug is on the other side. Look at those apples. Huh? Tell me that is not the cat's meow. IAEI News Live with this guy. I love it. So we got a mug now. And I'll tell you what. I think there's big things in the future for mugs like this. A mug like this on a mug like that. You gotta love it. It'll make any mug a good looking mug. So, I don't know if we're gonna start making these things forever and maybe get a limited edition series or something like that, but you gotta have one of those mugs. So, anyway. Let's talk energy management. Now, to talk energy management, let's do this. Yeah. Let's try this out. Here we go. Are you ready? Energy management systems. Now, I have a manly coffee cup. I got a manly coffee cup. Look at that. Bobby Joe's not going to be mad at me anymore. Thanks, Jody. I really appreciate the mug. I appreciate the effort, the thought, and you are absolutely awesome. All right. Let's talk energy management. When we think about energy management systems, energy management has been around for a very long time. I remember when I first when I started with the company that I'm with today, I worked with customers. This is 1996. So I was with an architectural engineering firm doing design engineering on commercial power distribution systems, fossil power plants, put a scrubber on a plant, and then I did nuclear. And then I came to work with my organization. And when I first started in January of 1996, here, I was working with customers, large industrials that were employing energy management systems, but what they were using it for was to avoid a peak demand charge from the utility. So their motivation and their efforts were financially driven from a awareness of their energy usage, promotion within their ranks, within their company to reduce energy usage, and rewards for that. In many cases, say an industrial facility was manufacturing a widget. They could tell how much energy it cost to make that widget. And then what they would do is they would put in the budget for that department so many dollars annually or a month, which would transpose into an annual budget for energy usage. And then what they would do is they would say, look, if you can reduce your energy, if you can manage your energy and reduce the amount of money you're spending on that budget item, you can use that money elsewhere. And what more of a motivating factor for a facility, for an individual who's in charge of moving money from bucket to bucket, than to say, look, if you save money on energy, you can use it elsewhere. It's your budget. And here are tools that you can invest in to help you manage your energy usage. So that was the drive back in the mid-90s. And then we have the migration of an energy management concept in regard to the National Electrical Code. So when I think of energy management and the NEC, a few articles and sections come to mind. The first spot that I believe we saw energy management in, and I could be 100% wrong, but I know for me on panel 2, my first exposure to this concept was in Article 220, in section 220.70, where we talk about the recognition of having an energy management system and acknowledging the energy management systems. When we talk management, you got to remember, it's more than just monitoring. It's not just awareness. There has to be a control aspect. Because if I'm going to adjust my load calculation based upon a set point in an energy management system, that I'm going to rely on, such that the energy management system is going to say, look, I'll make sure that you don't exceed this number of energy usage by doing what? Turning loads on and off. That's managing energy. Now, you might hear someone say, you can't manage it unless you monitor it. That would be an accurate and a very fair statement. But when I'm talking about the NEC, energy management is much more than just monitoring. There has to be a control aspect to it. I can't rely on another individual to constantly watch the energy usage and make decisions based upon the data. So, the first place in our journey that I want to stop or take a look at is what we find in Article 100 for the definition of what an energy management system is. So an energy management system, Article 100 defines it as a system consisting of any of the following. So, I mean, I've expressed this before. I think I've expressed it online. I know I remember here, just just remember, everything you hear started here, came out here, hopefully started here. Sometimes it starts here, okay? So, but I do the best I can to have it start up here, come out here, and it be from the heart. Based on safety and based on what I'll convey to you. Hopefully, I try not to put my opinions in, but if I do, I'll let you know them. And if you don't have an opinion, just call me. I'll give you an opinion. And I know we all do, especially when it comes to the code. But I do not speak on behalf of NFPA. I don't speak on behalf of NEMA, Eaton, IAEI. What I say is my opinion. You will have yours. I don't speak on behalf of Code Panel 13, Code Panel 10, Code Panel 2, or any of the Code Panel members. I'm just basically telling you what I'm reading, and it is what it is. So, this is the definition. What we have: an energy management consisting of any of the following. A monitor. I could have just a monitor, and it would be considered a monitor that monitors an electrical load or a power production or storage source. So if I have a monitor and it is monitoring the amount of kilowatt hours of an electrical load or kilowatts or current of an electrical load or a power production or storage source, then technically I have met the definition of an energy management system. It's all I need is a monitor. Or I can have some communication equipment. I can also have a controller and a timer or any other device that monitors. So an electrical load, what would be, I could have my phone, which is now on this tripod that I'm using to record this or display this. But with my phone, I can go to a little application that's connected through the clouds to a devices in my home, and I can tell you how much current, what circuits are on, which ones circuits are off, and the ones that are on, I can tell you how much current they're drawing. So technically my phone, it's a monitor, and it monitors the electrical load in my home. So my phone would meet the definition of an Article 100 energy management system. So then the next question, remember how we use terms in the code. Once you have something that meets the definition of a term that is in Article 100, then what do? We go back to the code to find out what requirements impact, in my case, my phone. Because my phone, it monitors an electrical load or a power production or storage source. So my phone is a monitoring system. Now, if you look at the definition, it says that monitors and or controls. Now, if it said and controls, well, my phone would still meet that, because my phone, I can turn loads on and off in my house, and I would demonstrate that, but I don't want to scare my wife. So I can turn my lights on and off remotely. What else can I do? My lights can go on and off. I can turn the receptacles on and off remotely. So there's, I think that's about it. I have a camera, and if I'm in the picture, I'm monitoring a load. But in any case, let's continue. All right. Now, if I look at what products, well, before I go there, Article 750. If we go to Article 750, we go to Article 750 is energy management systems. What it'll tell us in 750.6 is that an energy management system shall be one of the following: listed as a complete energy management system, listed as a kit for field installation in switch or overcurrent device enclosures, or listed individual components assembled as a system. So I could take a bunch of relays, as long as all of those relays are listed, and I put them all together, I've met the listing requirements in 750.6. I don't have to list it as a system. I just have to have all of the individual components assembled as a system, but the individual components are the ones that have to be listed. At least that's the way I read it. Listed individual components assembled as a system. Now, it doesn't say individual components assembled and listed as a system. It says listed individual components. So I can have a bunch of listed individual components, assemble them together as a system, and that could meet the requirements of energy management system that's been listed. Listing requirements. And item 2, it says listed as a kit for field installation in switch or overcurrent device enclosures. Those would be those devices that we would find, say, in a panel board, in a residential panel board or a commercial panel board, where they're putting the components inside of the panel board. It has to be listed as a kit. Now, if you look in 408, Article 408 of the NEC, it'll tell you that you, actually 408 and 408, and in Chapter 3, Article 312, cabinets, cutout boxes, and meter sockets will tell you gotta find it in 312. Where is it at? There it is. 312.8 says power monitoring and energy management equipment. 312.8b. Power monitoring and energy management equipment. The wiring space of enclosures for switches or overcurrent devices shall be permitted to contain power monitoring or energy management equipment in accordance with 312.8b1 through b3, and it speaks to what might be found in Article 220. Just give you an example. 220. All right, so here's what we got in 220. We say that if an energy management system is used to limit the current to a feeder or service, it's not limiting the current to a feeder. maybe to a feeder, or the current flow through a feeder and from a service, not to a service. So if you use an energy management system, you can use a single value to the maximum ampere set point. So what this is telling you is that the same on my end tool. I'm not sure what, so Jody wages. You got a circle. You've got a circle, refreshed. Greetings from Robert. I don't have any drop frames. My CPU is at 9.6, and I believe everything is, I'm broadcasting. So, Jody, I'm not sure on your end. I don't have any buffering issues on my side. I've got a really good heavy pipe going out of here. I have 0 dropped frames, so I have a very strong signal, guys. So hopefully you're looking at this, and I look on my restream. It says I have a good, excellent connection. So I'm good on my side. If you're experiencing any delays, check your do a refresh. So let me look. I had a couple things come in. So, all right. Nope. Yeah. So hopefully it's all working out for you. All right. So if I am going to leverage in Article 220 for my load calculations, the set point of an energy management system, I have to consider it a continuous load. But here's the thing. What happens if your energy management system goes down? Let's say it's driven by a computer or it's driven by a cloud, and your internet service goes out and you get the circle of death. Okay, Jody and David, the broadcast was buffering for a couple of minutes. It's working now. All right, perfect. So let's say, for example, Steve roaming in the house. I'm not sure what happened, but let's say, for example, that your energy management system experienced what some of you experienced. And we did that on purpose. Yeah, that's the ticket. We purposely delayed and the buffering to prove a point that what happens if your energy management system does that. And at that time, you're drawing more load than what the set point is permitting, and you're not managing the load. Now you can trip the main overcurrent device for a facility. That can be a safety concern. You can trip a feeder. That could be a safety concern. You could overload something if you're relying on that set point. And that would be what we call ungood. So the question is, what are the requirements if you're going to meet 220.70 and you elect to use you're going to use your phone, and your phone, you're going to maybe have, there's those apps that say, when something goes greater than, like, for example, I use an app on my phone such that every night and I have to change it for the time of day, but every night, say around 8 o'clock, my front and my back lights outside come on. And then around midnight, they shut off, or 1 o'clock, or whatever my time said. I can't remember what it was. But I set a time for my lights to come on and my lights to come off. I do the same thing for in the living room. I have certain lights in various areas where Bobby Joe, every night she would walk around, turn certain lights on in the house. And I employed the technology to turn those, manage the energy usage. Can I do that? What's the next step? So now I've got a phone. I can manage my energy usage. I'm gonna put a load study in my my design packet that I'm going to give to my electrical inspector. And when it says, what is your energy management system? I'm going to say it's iPhone version 16.1.3. And the application is Tommy D's Lighting Services. Well, is it okay? So 750 is where we would go to say, hey, how is it listed, right? So we would come over to 750 to the energy management, and we would look at 750 750 what was the number? 750 chapter 7, I would go to 750, and 750.6 would tell me, hey, Tommy D, it's got to be listed. It has to be listed as a complete energy management system, or listed as a kit, which I'm going to say, look, I'm not putting it in a panel board. I have these little devices that are in my house that I can turn on and off, so I don't have to worry about two being in a switch or overcurrent device enclosure. Now, the listed individual components, well, those little items, they're listed as little switches. So technically, could I make the argument to the inspector that each of those components are listed little switches, and I've put them all together and it works as a system? Now, my phone's not listed to anything outside. I mean, I don't know what they list the phone to, but all of those little individual little contactors that I have that I'm communicating with, and they all communicate through Wi-Fi up to a cloud and back down again. Those are listed individual components, but what are they listed to? The code doesn't really tell me to what they need to be listed to. There's no little informational note giving me any guidance. So I did some homework. I said, what would I list these to? So what I learned was that there's a standard. There's a UL standard for energy management equipment. Aha, grasshopper. Now, those individual contacts, maybe they need to be listed to UL 916 because it says energy management equipment. And they added, you're gonna love this, at the front of this UL standard, it says in 2021, which wasn't that long ago, they added changes in Supplement SA to address energy management equipment that uses remote or cloud-based interface for communication. Remember, I just said my iPhone communicates to the cloud, communicates to a relay down in my house that I can turn lights on and off. Those are listed components. My phone uses, but my phone's not listed as a system. But now we have in Supplement SA in UL 916 clarity on a cloud-based interface for communication and to clarify functional safety requirements referencing UL 60730-1. So I do have a standard. I have actually two standards, 60730-1 and then 916. So what I might want to do now, I think that we could have the debate and we can have the argument, and maybe we can even do some mud wrestling on whether or not it has to be listed as a UL 916 in its entirety as a system or the individual components. I don't know that the code is that clear, in my opinion. Do I think we have some work to do? I think we do. I think we might have to do some work in Article 750. Now, David is pointing out 750.6, and that is that's the listing requirement, right? Now, the other aspect in 750 are your load management, 750.30. They made some changes in 750.30. Now, 750.30 is tight. Now, remember, Article 750 is pretty small. You have a scope. You have the listing requirement in 750.6. You have the fact that they recognize in 750.20 that you don't want to interfere with fire pumps, healthcare facilities, energy management, emergency systems, legally required standby systems, or critical operation power systems, right? You don't want to shed loads that are safety related. And then they talk about load management in 750.30. They say that energy management systems shall be permitted to monitor and control electrical loads and sources in accordance with A through C. A talks about load shedding controls. B talks about disconnecting power. C talks about the capacity of branch circuit, feeder, or services. And it says, an energy management system shall not cause a branch circuit, feeder, or service to be overloaded. If an EMS is used to limit the current on a conductor, you have to have a current set point that you have to have you have to think about system malfunction. The EMS shall use monitoring and controls to automatically cease current flow upon malfunction of the EMS. So you still got to follow that. Even if, so here's the thing, 750.6 deals with listing. But we still have other requirements. Even if my little system, my phone, communicating with those contactors, little contacts out there in my house, using the cloud, I can say, well, look, I meet number 3, listed individual components. I have all listed individual components. We can, I don't know, we can have the debate. I don't even know what the listing is on a phone. But in any case, I can say all of my components are listed. And I've met 3. But I still got to follow 750.30. For my little energy management system. I can't interfere with any fire pumps, emergency systems, etc. We already talked about that. It says, it shall not cause disconnection of power for elevators, escalators, for positive ventilation. So again, all safety-related circuits, I can't interfere with those safety-related circuits. Then, when it gets to capacity, and remember what we said about 220, we said Article 220, I have to think about my set point for my load calculations. If I'm going to size my service and feeders off of this, I want to make sure that I don't overload my circuits. So a single value, so in the capacity, it tells me I can't cause a branch circuit, feeder, or service to be overloaded. My set point, a single value that's equal to the maximum ampere set point of the EMS shall be permitted for one or more of the following: calculating the connected load for 220.70, we talked about, for the maximum source current permitted by the EMS, so my little phone connected over there, I'd have to ensure that. And I'd have to prove to the inspector that it will not do that. Well, mine doesn't have that ability. My phone connecting to those components doesn't have the ability to determine what the maximum load current is. I don't have that logic. All right. Then it says system malfunction. The EMS, the energy management system, shall use monitoring and controls to automatically cease current flow upon malfunction of the EMS. Well, if I lose connection with my phone, those relays don't automatically turn off. So my phone wouldn't meet the requirements here in 750.30C2 for system malfunction. And I would say, my phone's, if I turn my phone off, it doesn't automatically turn the lights off in my house automatically. I wouldn't want it to do that because my phone, I'm not using my phone and those relays for anything related to the NEC. But if I did, I would have to make sure that I meet the NEC. Now, here's the other question. If you're looking at let's say that somebody puts one of those contacts in a circuit that's in an Article 700 system, and you see this little brick. It's got contacts, it's got termination 120 in or 240 or whatever, and the same out. Then you ask the question, what is that thing? And they say, oh, well, Tommy D likes to turn those lights on and off. Well, those are safety related. That's a life safety circuit. You can't have that equipment in the life safety circuit because you can't have you don't want, and you want to avoid having a system that you're turning off those emergency loads. That would violate what? That would violate 750, or actually 750.20, fire pumps, healthcare facilities, emergency systems, not controlling necessary to ensure continuity of those power systems. 750.30b, energy management systems shall not cause disconnection of power to the following: elevators, positive mechanical ventilation, circuits supplying emergency lighting. Yeah, Tom loves to turn lights off in the facility, but you aren't going to put that little contactor so that Tom can use his phone and turn off those emergency lights. That violates section 750.30b, right? So back into 750.30c, we had the current set point. We had the system malfunction we have to take care of. Then we have settings. Adjustable settings shall be permitted if access to the settings is accomplished by at least one of the following: located behind removable and sealable covers, located behind a cover, located behind locked doors, etc. So if I put the settings, let's say that I had the capability on my phone to put settings, I would have to make sure that they are locked behind, that they're password protected, with password accessible only to qualified personnel. And then finally, there's a marking requirement. The equipment that supplies the branch circuit feeder or service shall be field marked with the following information: the maximum current setting, date of the calculation, identification of loads and sources associated with the current limiting features, and then the following or equivalent wording: the setting for the EMS current limiting feature shall not be bypassed. And they have to meet all the requirements of 110.21b. So, it's important. This is a good, this is a good example. This is a good example of, and I've heard people say, well, hey, you've got a listing requirement. Why do you need to put all of these items in there when you have a listed product? Well, the requirements in 750.6, I think, leave a little bit to be desired, the way it's written. But the requirements found elsewhere in Article 750, I think, fill some of those gaps. So, in my opinion, I wouldn't be able to use my phone and those little components I have back at my house to address the requirements in the energy management system for 220, etc., because I wouldn't meet the rest of the requirements in Article 750. Not because it's not listed, because my components can be listed, right? There's nothing that says the entire system has to be listed as a system. It just says the components have to be listed. And I can have those listed. I can have all the individual components, and then I can assemble them to get whatever it is I need to get done. But my little solution here would not pass the smell test of an Article 750 review. Well, that's a good point. So David Engelhardt says he's curious. The International Energy Conservation Code, the IECC, doesn't appear to recognize energy management systems and UL 916. You know what, David? It might be in the future. In the future, we might have to go back to the future. Maybe we need one of those. We need a DeLorean. We need a DeLorean, a flux capacitor, and a little dog. So in any case, so that's just the beginning of the journey. We're not done yet, David. So 916, that's a UL 916 is a good one to look at. 60730-1 is another good one to look at. Now, we already talked about 220. How about 625.42, David? An electric vehicle supply equipment. It has to have sufficient rating to supply the load served. The electric vehicle charging loads have to be considered to be continuous loads for the purposes of the article. So Service and feeders can be sized in accordance with the product ratings, unless the overall rating of the installation can be limited through controls as permitted in 625.42 A and B. You know where this is going? This is going to energy management. So A is an energy management system, and then B is EVSE with adjustable settings. So let's take a look at A, because that's the title of this broadcast, where the EMS is in accordance with 750.30, which we just went through. Remember, I told you, I can have something, I have individual components that may pass the smell test of a 750.6, but it may not pass the test of 750.30. Now here we have 625.42 specifically pointing out 750.30 requirements. The maximum equipment load on a service and feeder shall be the maximum load permitted by the EMS. If you are sizing your feeders and your services based upon a set point of an EMS, how do we know what happens when the brain goes south? Right? My boss has been asking that about me for years. But I'm not listed. I didn't even come with instructions when I was born. So anyway, the EMS shall be permitted to be integral to one piece of equipment or integral to a listed system consisting of more than one piece of equipment. You saw that in 750.6. When one or more pieces of equipment are provided with an integral load management control, the system shall be marked to indicate this control is provided. This is where the system is brought into the picture. It's not brought in 750. We saw that, right? Because 750.6 lets me list individual components and then assemble them as a system, but the system doesn't have to be marked or labeled or listed. But here we have in 625.42 a reference to the system being marked to indicate this control is provided. It doesn't say it shall be listed. It just says marked to indicate the control is provided. And then B, it deals with the settings of the EVSE itself. So the adjusted ratings shall appear on the rated label with sufficient durability, blah, 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 blah. And it references 750.30C. And we remember what 750.30C was, right? I don't know if I still have that up. 750.30C capacity of the branch circuit feeder service. You have the current set point, you have the system malfunctions, and you have the settings, and you have marking requirements. All there in 750.30. Charlie. All right. So that was 625. Now, how about 705? What is Article 705 all about? Article 705. Article 705 is all about, well, you know what? I'll tell you what it's all about. Let me tell you something. So here's what we're going to do. I'm going to go to 705, not 750, 705. And I want to read the scope. It says, this article covers installation of one or more electric power production sources operating in parallel with a primary source of electricity. So 705 is only when you have sources of energy that operate in parallel with a utility. A generator, when there's a transfer switch, is not a 705 system. If you have an electric vehicle and you're going to tie in the electric vehicle, use it as an alternative source of energy to power the house. When the power goes out from the utility, you're going to have a manual transfer switch. You plug in your vehicle and your vehicle is powering. That vehicle that's powering the structure is not operating in parallel with the utility, so it would not be a 705 system. 705 system is only invoked whenever you have one or more electric power production sources operating in parallel with a primary source of electricity. And the primary source, they give you an informational note to help you understand what is a primary source. It says, examples of the types of primary sources include a utility supply or an on-site electric power source. So if you were a facility where you had your own source of power and you weren't connected to a utility, say you had a blast furnace, or not a blast furnace, I don't know, say you just produced your own power, period. You had a generator, you had a creek outside the house, and you put a generator in there and a turbine, and you generated your own power, and that's your primary source of power. If you added PV and you operated in parallel with that, then yeah, you're in an Article 705 interconnected system, brother. Okay? But if you're a standalone, you're not in 705. All right, so having gotten that out of my system, I feel better now. I don't know about you. Let's take a look. An EMS in accordance, so an energy management system, 705.13. An EMS in accordance with 705.30 shall be permitted to limit current and loading on the bus bars and conductors supplied by the output of one or more interconnected electric power production or energy storage sources. So, if I am, remember, when we're connecting downstream of the service, okay, David, if I'm connecting into a panel board, a switchboard, whatever, downstream of my service, I'm going to decline. Sorry about that. I don't know if that did anything to my thing, even Bobby or whatever. I don't know. But in any case, if I'm downstream of my service, I have to make sure now. So I have, what do I have? I've got a box. I have a main breaker. And I have this going on, right? And let's say that down here, I connect to an inverter, and this connects to, I don't know, because it's a little bit easier to draw. Look at this, David. All right, so this is called a windmill. So I've got current coming in here. Let's say this is 200 amps. And let's say this is 60 amps. Then I can have loads my loads (260 amps). I can draw 260 amps because I have capacity coming from the utility up here. So I have utility capacity here. I have from my wind or alternative energy, I have capacity, and all of these are my loads. I can draw more current than what this bus can handle. So I've got to be careful about how I design my system and make sure that I don't overload the bus. And in 705, it gives me rules and regulations to make sure that I don't exceed that bus rating. And based upon what we just read in 705.13, I can manage that flow of current to make sure that I don't exceed the rating of the current on the bus bars and my conductors by leveraging an energy management system. Now that, my friend, would be a safety-related function for an energy management system. I'd want to make sure I'm crossing my T's and dotting my I's. Because if I'm relying on a set point and I'm relying on the system to get its job done and not screw this up, it better do its job, and I better understand the fail-safe modes. In 705 and 750.3, we already talked about the load shedding controls, the disconnection of power, and the capacity, branch circuit, and feeder services. And then the capacity of branch circuit and feeder services, we already talked about the current set point, what happens when a system malfunctions, how do I handle the settings, and locked covers and all that jazz, and then how do I need to mark it. So 750.30 is a very important section in the code to make sure that we are crossing our T's and dotting our I's, and so is the definition of an energy management system. You've got to know what an energy management system is, and then when you're using it, you got to know that you're in Article 750 if it is an energy management system, and if you're using it to meet the requirements in 220 for load calculations, 705 for interconnected systems, and 625 for those electric vehicle chargers and supply equipment. So all of these things are related to each other. Now, in addition, again, we said if you're going to put an energy management system in, you're going to put something in a panel board enclosure, you're going to make sure you meet the requirements of 312.8b. And we already talked about those and what you can and cannot put in the box, right? Power management control, 551. Look at 551. 551 is in your recreation vehicle. Each recreation vehicle containing an AC electrical system shall contain one of the circuit arrangements in 551.42a through d. One 15 amp circuit, one 20 amp circuit, 2 to 5 15 or 20 ampere circuits, and then more than 5 circuits without a listed energy management system. So if you look at 2 to 5, it says 2 to 5, 15 or 20 ampere circuits to supply lights receptacle. Such recreation vehicles shall be permitted to be equipped with panel boards rated 120 volt maximum and listed for 30 ampere applications supplied by the appropriate feeder assemblies. Not more than 2 120 volt thermostatically controlled appliances shall be installed in such systems unless appliance isolation switching, energy management systems, or similar methods are used. So there's another recognition of an energy management system in Article 551. You may or may not have even known that even existed. 551.42, more than 50 ampere 12208 feeder assembly and minimum 50 ampere rated panel board shall be used where 6 or more circuits are employed. The load distribution shall ensure a reasonable current balance between phases. 551.42, again, this is C, 2 to 5, and these are exceptions. I have this out of order. So you have some exceptions, and again, there's a recognition of an energy management system there. 702.4, remember 702, this requirement went in the code, and the stimulus for remember, in 702, this is your optional standby systems. Oh man, I don't know what year it was. Everything's molding together in my head right now. But in any case, there was a time when we put a requirement in that says if you have an automatic transfer switch, the generator has to be sized for the load. Remember that? So in 702.4, the capacity, manual or non-automatic. Now, if it was non-automatic, you didn't have to worry about it. If it was manual, you did not have to worry about it. But if it is an automatic load connection, an optional standby system shall comply with 702A or B. A talks about the standby source shall be capable of supplying the full load that is automatically connected, or you can employ an energy management system, and we have transfer switches. The industry has transfer switches that will automatically do the load shedding so that you don't exceed the rating of the generator to accommodate 702.4A to B. So there are solutions out there that we rely upon to keep us out of trouble. And we want to make sure that when they're used correctly. Now, the question would be, that transfer switch that employs a 702.4A to B load and energy management system, how does it need to be listed? If you go to 750, what are my options? I list it as a system. B, it's listed as components that go inside of equipment, as a retrofit type of deal. Or C, individual components listed and assembled as a system. I could possibly say, look, this is meeting C. It doesn't need to be listed to the UL standard for energy management systems. I could make that argument. I don't know if I'd win that argument, but I could make it. I'll argue about anything. I'll argue with you. But show me in the language in the code where it says it has to meet that UL standard. It doesn't really say that. Do we need to improve that? I think maybe, if that's our intent. I don't know. 23082, energy management systems can be connected to the line side. We had this discussion last week, right? And I love this. Conductors used to supply energy management systems, circuits for standby power system, fire pump equipment, blah, blah, blah. If provided with service equipment and installed in accordance with requirements for service entrance conductors. So we've got a recognition that an energy management system can be connected to the supply side of the service disconnect. Eric Hammond, welcome. It's better. Eric may be late, but he's worth the wait. But wanted to say hello. Eric, hello. Thanks for joining us. Now, that is what I am known to say. Sweet. I love it. I love it. All right. So, as you could tell, I'm in a monitor farm. On this farm, we plant monitors when they're young in the ground. And then as they grow, when they become big monitors, we put them in this monitor farm and we let them grow. These monitors here are relatively young; they're teenagers, but when they grow up, they're going to be big 55-inch monitors. So that might take a few years, though. So welcome to the monitor farm. So Eric and all of you out there, I hope that our discussion today on energy management systems may have spurred you to think about some public inputs for next cycle. I think that we need to think. That's usually our first mistake when we start thinking. But I believe we need to take a look at some of the requirements in 750. Take a look at the system, the listing requirements, to see how is this supposed to be listed. Do I have to list these as a system? Do I not have to list them as a system? How do I address it? So, what are the listing requirements? What do we mean by an energy management system? Do we really mean in the definition that an energy management system can just be monitoring only? I think the definition needs some work. I think it needs a little bit of love, David. I think we need to take that definition. We need to hold that definition. We need to review and talk to the definition and then come up with what we need to do to dress that definition up so that it becomes a big monitor one day. Because in my opinion, when I look at the definition of when it says a system consisting of any of the following, I think that it should say and controls an electrical load. It's not an or. That's sort of where my head's at. I don't know if that's true, if that would hold true, but I believe we need to give it some attention. So energy management systems and the NEC is not a simple topic, in my opinion. It's kind of complex, a little bit complicated. It's out there in various sections of the code. Use NFPA link and find all of those areas where the term energy management system or energy management or power management. You know what? That's one thing I did not do. Let's take a look real quick. I am going to come back. We're going to come here and we're going to search all of NFPA and we're going to do power management. I'll first search for power. Oh, power, fault managed power. That's new. That's fault managed power. Power monitoring and energy management equipment. Okay, so power monitoring in 408. So if you're going to do power monitoring, see, that's David, this is what I think. I think the moment you say power monitoring, you're monitoring. When you say energy management, you're controlling. The definition doesn't reflect that. The definition for energy management says and or control. And in my opinion, Tommy D, starting up here, coming out of here, straight from the heart, I think that we need to put and control in that definition. Power monitoring is separate. Maybe we need to define power monitoring. And we use in 312 power monitoring. Oh, 312, it's the same section. Power monitoring and or electrical equipment. So that's the nice thing about NFPA link. And you can search across many different documents. I don't make any money on NFPA link. I don't get any kickbacks. I'm just telling you it's a good tool. And my IAEI membership. I'm telling you, I don't make any money off of each individual person who signs up because they said, hey, you know what? I was watching IAEI News Live and I want to join the IAEI, or I was out at the Western section, or I was at the West by God, Virginia chapter, and I want to join the IAEI and become a part of the electrical industry and influence and mingle and learn with the electrical industry through my relationships that are generated from the IAEI. I don't get any kickbacks for that. The kickback I get is your engagement and your knowledge that you can share with me. So I would beg you to please consider the IAEI as a resource for you, and your membership can have its value and provide value to you in your career, in your engagement with the electrical industry. So please consider membership in IAEI. I would love you if you simply subscribe to the YouTube channel. But here's another very important piece of the puzzle, David and Eric, Southern Section Rules. Here's another important piece of the puzzle. Share. You can take this link, take this video or any of the videos that we have out there on YouTube. Go to YouTube, there's a little double button, or a little thingy-me-bob, or whatever you want to call it down the bottom. It says share. You can post it to your Facebook, your LinkedIn. You can put it in an email and send it to your friends and say, I heard something that sparked my interest. I'd love your opinion. Is this guy a nut? Is he right? Is he wrong? Do you have ideas on how we can influence and change the electrical industry to increase safety? Let's work together. So share the content in addition to subscribing and hitting that thumbs up. The IAEI very much appreciates you. I appreciate you. And remember, in case you came in late, we've got a coffee mug now. And now I don't have to sit with my wife's flowerful coffee or her coffee cup that has a big B for Bobby Joe. I have my own cup that says live with Tom. So thank you, Jody, for the cup. Thank you for all each of you do, and thanks for joining in on our discussion and chatting it up a little bit. I appreciate that. I tried to watch the chats as much as I could. I apologize if there was any delays out there. I can honestly say I've had a very good connection here. 0 dropped frames. I'm streaming at 1080. I'll tell you what I'm streaming at. I am streaming at I'm at 1920 by 1080, so I'm streaming in 1080 at 2839 kilobauds, 30 feet per second, 30 frames per second. I see FPS and I keep saying feet per second, and everybody goes, what's he talking about? Frames per second, and my keyframe interval is 2 seconds. And yes, Nihad, I do have an Egyptian coffee mug. You know what? Here's the thing I do, Nihad. I use your coffee, your mug, my Egyptian mug for tea because it's a little bit smaller. So I use that mug when it's tea time. And I don't golf. So I'll shoot those golf balls out of the air, but I don't swing a club. You don't want me swinging a club. So thank you, David. Take a look, and I'll take a look and see if there were any buffering issues as well. So I appreciate that. Yeah, with all those recording specs, I might hurt the young growing monitors' feelings. No, you know what, Eric? They're listening, and I can hear them talking to each other. They're going, one day we're going to grow up to be 1080. We're going to grow up to be 1920 by 1080. And then there's a few that have already blossomed to that regard, and some are in the 4K mode. You are all possibly in the future going to be 4K participants. So, Eric, the monitor farm, there's not too many monitor farms out there here in the United States. I'm just saying, I think this is going to be the future of our industry right here. Brings a tear to my coffee mug. So, all right, everybody. Yes, I am Nihad. Thank you very much for the Egyptian mug. Nihad carried it all the way from Egypt. I'm going to learn how to read the hieroglyphics on there one of these days. All right. Thank you, Eric. Thank you, Nihad. Thank you, David Engelhardt, and everybody else who joined in for this session of IAEI News Live. I look forward to your IAEI membership. I look forward to hopefully one day meeting you in person at an IAEI meeting somewhere. And thank you for what you do for the electrical industry and electrical safety. Stay safe, and please, stay healthy. We will see you next week. All right. Ciao.